that Aiden or whoever else can be benefited by the change of base. So change of base formula says that if we have log base A of B, we can turn this into the log, or the natural log, either one, because both of those buttons are definitely on the calculator, of B over the log of A. So you can always just do that and not even worry about the catalog and all that and try to remember where the heck all that crap is.
Oh, I have written down.
Yeah. Yeah. You can always just use that. And if you feel like it, you could even change it to this if it makes you feel happier.
What's the difference
Same.
between the two?
Well, one of them's base 10, one of them's base E, right?
Oh, yeah.
Log with nothing there is base 10, and then the natural log is base E. Okay, so answers. Let's see, we did 2 through how many?
40.
40, evens, great. Number 2 is 1. Number 4 is 1. Number 6 is 3. Number 8 is negative 2. 10 is 2. 12 is negative 14. 14 is approximately equal to 0.936. 16 is approximately equal to 6.88. 18 is approximately equal to 0.356. Number 20 is negative 12. Number 22 is 21. 24 is 3. 26 is 8.322. 28 through 32, give me a second and I will stick it on the television.
So if I just plug it into the calculator and got the right answer, it still works?
That wouldn't be enough. You need to be able to do those without it. You could certainly check it on the calculator because you will have access to it. You don't get your calculator removed until trig. And that's only for part of a test. Let's see, what is it? 3, 2, numbers 28. Okay, 3.
Like the trig class or the trig part in pre-cal?
There is a test in pre-cal in which you will have a no calculator portion of the test.
Is this pre-cal or is this like advanced math?
This is pre-cal.
Advanced math is something that only exists in Saxon because they're stupid. And what they really mean by advanced math is pre-cal. That's the only place where that exists that I'm aware of.
You were talking about pre-cal the other day for some reason. I don't remember why.
I see. This class is Precalculus. Oh, I guess it helps if I project it. Here we go. Smart view. Kablampo. Yeah, there's uno mas, but I guess he's still sick or something. There you go. There's 28.
For the x-intercept, 0, 1 is also acceptable, right? 1, 0. Okay. 1, 0.
Yes. Yes. No, it would be 0, 1. That's right.
It'd be 0, 1.
Oh, no, x-intercept.
Yeah.
Not the y-intercept. Yes. Yes. Yes.
And asymptote says I could be vertical asymptote x equals 0.
Yes. Which is arguably, well, I don't know, the y-axis is not a terrible answer either way. So either one is acceptable. All right, number 30 looks like that guy.
Oh, there's 2.
Yes.
Infinity.
Because, let me see, probably in the instructions, I don't know, let's see. Sketch and analyze the graph of each function. Describe its domain, aim, range, intercepts, asymptote, end behavior, and where the function is increasing or decreasing. So, I don't know what, no, the bottom one is the one that's right. So what they did, let me flip I should have done this before. Sorry, Aiden or whoever else. Whoosh, look, you are in 2 videos. There you are. Oh, too late. You missed it. Had your chance, muffed it. Okay. Okay, great. Well, you were in before. You just weren't aware. What they did on the answer key is they did the exponential one. So this is the exponential function, which would be the inverse of this one. And so they just show there. I don't know why they did that. It's probably in how they explain how to solve this stuff in the thing, I'm sure. Because that's what the log is. It's the inverse of the exponential one. And so that's what this one is. This one here is the actual answer to the problem. All right, so let's see. We need 32, which ought to be similar. Oh yeah, and it's crazy because it's got a 1/5 base.
Okay.
Oh, there's a bunch of others too. Let's see, let me take a bigger picture. Hold on. Okay. So 32, whoa, that's exciting. Hello. Try again.
You want me to staple it?
No, I'll take care of it. There we go. Oh my gosh, you got this. 32 is that. So all of you on the back row, this is in your future, even in the class you're taking. Just later in the year. And possibly slightly less complicated and without a graphing calculator, so you know.
Are those like little infinities like everywhere?
Yes.
Yes.
Because the graph goes on to infinity.
Seems like there's an excessive amount of them.
So 34 is right there, and it's just the graph translated 4 units to the left. G of x is f of x translated 4 units to the left. Easy money. Inside the parentheses, opposite, right? 36. Compressed horizontally, right? Yes. Because if you were just looking at the graphs and we were talking about it without the equations and you were talking about it vertically, then it would be stretched, right? So yeah, it's horizontally compressed. Inside opposite. You did what?
I got it correct, just incorrectly.
Okay, okay. All right. 38 is right there, and it's a reflection and translated 2 units to the right.
Can you say inverted, or do you have to say it's a reflection?
Yes, reflection is a better word. I mean, I guess if you did inverted over the x-axis, then I might count that, but. And then finally, number 40 is that guy, which is g of x. Oh, you're right, thank you. G of x is f of x reflected over the x-axis and expanded vertically by a factor of 2 and translated up 5.
Wait, let me take a picture of that real quick.
All kinds of things happening.
It's okay.
Okay. So, what questions? 40, and we may want to, we were talking about like 20, 22, and 24 maybe?
And 8.
And 8. Let's grab at least one of those, and then we'll hit 40, and then we'll see what we do from there.
6, 14, 32, 36.
The joke, Garrett, would be 2 through 40 evens.
That happens literally every single time in Algebra 2. Every single time. And it's always people that sit right there. Not naming any names.
But if you want to go watch the videos, you could figure it out.
Yeah, exactly.
Would this be how to plug this in? Ever question mark?
Okay. On what? What are you doing?
On this function, sorry. G of x plus negative.
This is 40?
Yeah.
I don't need that. I've got it right here.
Okay, cool.
-2 log the 5 is not in parentheses. It's just the log of x and then plus 5.
Oh, okay.
Oh, that's why I got 41 probably.
Well, there you go. All right, let's hit number 6.
Not 6.
Well, six comes before
Yeah, I did actually.
20, so we're gonna do 6. Yes, and 6 is pretty easy, so it will take just a second to hit it. So I'm gonna start there.
Would we
Wait.
distribute the exponent and
No.
if had 8 instead?
No, see, it's way easier than that. There's a property you're not thinking about, which ironically, you actually remembered about it on Tuesday, but you have forgotten about it since then.
Tuesday?
Yeah. You remembered this property. You remembered it existed when I was explaining stuff. But you forgot about it when you were doing your homework.
3 to the cube.
Okay, so number 6 is like easy money, right? Okay, here we go. So number 6 is the log base 6 of 6 cubed.
Base 2 of 2 cubed.
Okay, same difference. We'll pretend same work. Great. Okay, so if we have a log base whatever of something with an exponent, what can we do with the exponent?
We can just write it.
We can pull it to the front, right?
Oh, yes, yeah.
So then we end up with 3 times the log base 6 of 6, or 2 of 2 if you copied the problem correctly, right?
And then
Then if you have log and the base and the argument match, what does that equal?
0 or 1.
1. Not or, but definitely 1. Right? So 3 times 1 is 3, so the answer is 3. Yahoo.
I got them all right, but it's because I plugged it into the calculator.
Well, yeah, so this is still important, right? Right. Does this make sense? Any questions on this?
Nope.
Okay, good. 20 is the next one that I'm going to do. I don't know what y'all are doing, but that's what I'm going to do.
You made that look very easy,
Because it was very easy. That one was very easy.
but it had scary words in it.
Number 20 is actually pretty easy as well, but let's break it down into its pieces. The natural log of 1 over e to the 12th. Okay, so you need to be able to do this without a calculator, okay? You need to be able to use properties of logarithms to get there. Properties of logarithms and exponents, actually. Okay, so if I want this e to the 12th to be in the numerator, what would I have to do?
Multiply by a singular.
No, I'm not going to, because the only, and this is muy importante, the only time you can start randomly multiplying by crap is if there's an equals.
Oh, yeah.
Or if you multiply something by something over itself, right? Those are the only options, right? So we can't start multiplying crap, but we can do something else. What can we do?
Factor out of 1.
I love the, see, this is what I'm talking about, where you're like moving from the pre-algebra you to the now you. You're like, okay, you're using words like factor out a thing. You're doing great. No, how about we just do this? Right?
Yeah,
If we do negative exponents, then it changes levels, right? So that's the same thing.
Oh, yeah.
1 over e to the 12th is the same as e to the negative 12th. Now what could we do?
Cancel the e and the ln since those are
Right.
both basic
Well, you got to pull the
numbers.
negative 12 out to the front, but yes. And then yes. So we've got negative 12 times the natural log of e, and that's 1, so the answer is negative 12. Wahoo.
Okay, we'll do 22. That
That's
was
a
one
14.
that-
Wahoo.
Oh yeah, 22 is a fun one. I like 22. Let's do it. It's also easy.
As we possibly can.
These are fun. These are fun kinds of problems. Number 22.
Answer to it, yes.
Oh wow, number 22 is even more fun than I thought. Okay.
Oh my gosh, log base 7 through 4.
That's funny. You wouldn't see a problem that was this weird in an Algebra 2 version of this, but it's just as easy as it would be. Of 64.
No, it doesn't look fun at all. I don't even
All
know
right.
what log
I
is.
love it. Okay, so what we really want to happen, because the property that we know is if like the bases match, then we can start just like killing stuff, right?
Ooh,
The
fun.
7 through 4. Or just 4. Square root.
Can we turn 64 into a 4?
Yes.
Yes.
How?
Divide by 1.
Divide by
16.
So divide by, sure, but I really want exponents, right? Because I've got exponents and logarithms, so I really want 4 with some sort of exponent.
Okay, so then.
Oh, that's not right.
So,
4 to the 3?
yeah.
Yeah.
Okay, so let's kind of start doing some things. Log base 4 to the 1/7
Oh, I know that.
of 4 cubed.
And then the 4's can go away.
Can they? Can they though?
Or
You need to take out the 3.
Okay, so taking the 3. Log base 4 to the 1/7. Are we following where the 1/7 comes from?
Yes.
Okay.
It just looks like magic to me, but as long as I know it's possible.
No, that's not good enough. Because then it's just going to be magic on the test and you're not going to remember it, right?
It's a root.
So when we have a root, so like for example, if we have the square root of x, remember that's x to the 1/2. But if we have like the 5th root of x, that's x to the 1/5. You remember this? If we have, just to make sure we're cementing things, if we have x cubed and then the 4th root of that, that's x to the 3/4, right? Remembering all that?
Yeah.
So the 7th root of 4 is the same as 4 to the 1/7. Okay, so that's the math magic that we're doing. Mathemagics. Okay, where do we go from here? They can't really quite go away because that's 4 to the 1/7 isn't 4.
Can we take out the 1/7?
Yeah, to the front? Is that possible?
So let's think about this a different way because it's hard to think in logs. And when we get a little bit like twisted up, it's hard to think in logs, but it's pretty easy to think in exponents because we've been doing it for a while. So what we're really trying to figure out with just this chunk right here, just this one, the 3 can hang out. The 3 can have a nice life over in his own little boonies, right? Well, maybe.
Because doesn't he?
Yeah, isn't he connected to it by multiplication?
Yeah, I was just trying to think. I'm just trying to think if there's an even easier way to think about it and just leave him where he was. That's kind of where I'm headed.
Oh, I forgot about exponential.
So let's back up to this step and let's convert from here. We could convert from here, but let's convert from here because I think it's going to be easier to see if we convert from there. Because we kind of got like a double stacked base, this weird like double stack thing. If we kind of introduce an equals x into the thing, because we're trying to find x, right? Because that's going to be easy to kind of think about, right? So we're trying to figure out 4 to the 1/7 to the what equals 3, right? So let's do that. So 4 to the 1/7 to the x equals 4 cubed. That's really what we're kind of doing there, right? That makes sense? We understand where what that conversion came from?
What's that? Exponential?
That's just converting this logarithmic form equation to exponential form,
Yep.
right? Okay, so now what do we have that's going to be useful?
Like bases.
We do have like bases, and we may even want to, you could probably skip this intermediate step if you wanted to, but if we have a power to a power, what do we do with those? Multiply them. So this, like I say, you could probably skip this intermediate step, but just for complete clarity, this would turn into 4 to the 1/7 x equals 4 cubed. And then, just like Bree said, we have the same base. So what can we do now?
Divide by the bases.
We don't have to, so that's not multiplied. But if we have the same base, we can just set the exponents equal if the bases match. So we can turn this into 1/7 x equals 3. And now that's super easy money. You've been doing that since pre-algebra. What do we do now? Divide by 1/7, which is the same as multiplying times 7. So we end up with x equals 21.
Okay, that's making more sense.
That's a fun problem. I like that one. All right, before we go
Doing it, I didn't like it.
before we go too deep into some other things,
Can we do?
let's do 40.
Let's do 40.
Let's do 40.
Lesson today? In class?
Yeah. What?
What are we doing today?
I think that's already assigned, right? Don't I already have assignments for like
Yes.
Tuesday?
We do.
Yeah, so no, we're not doing any notes in class today. Right? I have all that. That's okay.
all.
You scared me. I was like, I thought I was actually in a good place.
We're rushing through things.
I'm not, but I'm not trying to rush. I might like throw a quiz at you. Who knows? But I also thought we might ultimately practice a few more of these. We might do some of the odd ones.
Yeah.
Because this is not hard. Even this, like that's wild, isn't necessarily hard. You just kind of have to shove your brain into a different space, right?
Yeah.
And so it's not, and because of that, practice helps, right? So let's do 40. Make sure we get the crazy graph. Unless, do we actually need 40 anymore? You said you figured out what you did wrong with 40.
No,
Can we do
I
40?
think
Garrett's like, could we please do it? I'd like to do it.
I should do
It's
1.
right, but my graph is completely wrong, so I think I just plugged it into the calculator.
Okay. So we're supposed to graph g of x equals -2 times the log of x plus 5. And so we're noting that that's the log of x plus 5, not the log of x plus 5, right? This x plus 5 is not in the parentheses, it's not in the log, it's on the outside. So this is the k, not the h,
Okay.
right? Yes, k. And we're also supposed to compare that to f of x, which is the log of x, right? So we're supposed to compare those, and we're supposed to graph that one. We might graph this one too, just to make it easier to compare to, right? So, how does this change this?
It's going to shift to the left 5 and down 2 and deflected.
One of those things was wrong. Well, maybe two of them.
Okay, it shifts up 5 because.
Yeah, because this is k, right?
Oh, right.
Has the 5 outside the x parentheses.
Yes.
Can you put x in parentheses real quick just to make it easier to visualize?
I will put x in the parentheses.
Thank you. Okay, so the plus.
And then I'll
5.
take it away because I want you to be able to see it without it.
So that's what
How rude.
So since the plus 5 is outside of parentheses,
Yeah.
it's the one that indicates where it goes in the y-axis. So it goes up 5.
So it goes up 5.
Don't invert it.
It does reflect over where?
The x-axis.
X-axis. So let's start writing some of these things down. So it's translated up 5. It's reflected in the x-axis. And then what else is it? What does the 2 do?
2, like, stretches it.
It does. Stretches it by a factor of 2. Stretch vertically, factor of 2. Great. Let's make us a little table. What makes sense to pick for x?
It's gonna be.
It's still going to be the -2.
Let me ask a question real quick. Let me throw a curve. Does it make sense to put this?
No.
Yes,
Yes.
because the log doesn't have a base written, so that's log 10. Is that the right direction here?
halfway, but no, it doesn't actually make sense to put that. Where does this graph not exist?
On the x-axis.
It doesn't exist on the x-axis. Where else does it not exist?
Y-axis.
What does this one look like? What does the parent function like? If I'm just gonna like give a rough sketch real quick right here, what does this one look like?
Like this.
Does it have any asymptotes?
No.
It does have an asymptote. Has a vertical asymptote. Where? Y-axis. And it looks like this. Where does that's probably true. You were flailing about. Maybe so. Oh, maybe so. I didn't hear you. Okay, I didn't hear you. Okay, so it looks like that. With some asymptote here. What? What do you mean what? Did you watch the video or not watch the video? Put the dadgum calculator down. What does the parent graph look like? It looks like this. This needs to be in here, not there. This needs to be in here. This needs to be in here. This can be in there and in here. This needs to be in here. Parent functions need to be in here. Parent functions in here. Parent functions in here. That needs to be memorized. That needs to be able to done without the thing. I should be able to write some random parent function. You should be like, it looks like this, or it looks like this, or it looks like this. You should be able to do parent functions in your brain immediately. Okay. So this is what it looks like. Now, back to the original OG question. Where does this not exist?
On the y-axis.
On the y-axis. Where else does it not exist?
Negative.
Negatives. So there's not going to be, if I put negatives, it's going to be does not exist, doesn't exist, doesn't exist, doesn't exist, right? So we don't need negatives. Now, here's the other question. See, here's the thing. This graph is shifted up by 5, but not left or right. So this one is also not going to exist in negative, right? Easy money, yeah? Now, what you were thinking of was spot on. Putting a 10 here makes abundant sense.
Because then you can just get rid of the log.
Right. And you end up with -2 plus 5, and you end up with 3. This one you end up with 1, right? You can confirm that on your calculator if you wish, of course. Right? Yeah.
And then do we just
What about another one? What about 1/10?
So if it's
Let me write that different so it's clear what I'm writing.
It's log tenth of
How did you know that?
math.
I'll show you. You can also like shove it in the table and get the thing. But here, look at this. Look at this magic. -2 log base 10, because there's nothing there, of 1/10. How do we write 1/10?
10 negative 1.
10 to the -1. So this would be -2 times the log of 10 to the -1. What can we do with that -1?
We can take it out.
So we end up with 3 plus 5, and which is 8.
And then in the original, that would give us
7, right?
no, it just gives us -1. Because the original is just log x.
So this would be -1. Oh yeah, thank you. I was still looking at this one. I was confused. I think although this should be 7 and not 8, right? Why would this be a 3? What did I do?
Because you did -1 times 2 and then times -2, but then you added them.
Yeah, I added them for some reason. So that would just be 2. So that'd be a 7, and that would be just a negative, no.
-1.
Yeah, -1. Great.
We still need 1 on x, I guess. No. We need to
You
figure
can
out
put a 0 in there, sure. Log base 10 of 0 is what?
1.
1.
So then 1.
So that'd be 3. This one would be 1, right? Wait.
No, that can not be correct.
Something's wrong somewhere. What did I do? Did I do this one wrong? 10 to the, this one is actually 0, isn't it? Which means this one is actually 5, right? If we're putting a 0 in here,
Okay, so if you have log 10
yes,
is 0.
yes, yes,
negative
yes, yes,
0.
yes, 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 yes. Because 10 to the, wait, time out. That doesn't exist. What am I doing? That can't happen.
Yeah, it's undefined.
That's what happens when I try to do stuff in my head and then I get too excited. We want to know the x-intercept, so we want this to be 0, right?
Yes.
That would be helpful, right? So when is that 0? So then we've got negative 2 times the log of x. So negative 5 equals negative 2 log of x. Log of x equals 5 halves x. So 10 to the 5 halves would be the square root of 10 to the 5th. Which might be, what is 10 to the 5th? Somebody punch that for me. That probably has that might have a square root, or it's going to give us a decimal. Who knows? We're about to find out. Okay, and then square root of that.
Square root of 100,000?
Yep.
316.22776.
Sounds good. Okay, 306. I can write 16, and we just plugged in. Wait.
Are we sure we did this right?
And that's what I'm saying right there.
Why are we figuring out the y-intercept? No, x-intercept. No, we're not figuring out the x-intercept.
But that doesn't sound right though, does it?
No.
Let's see. Let me write it bigger with less trouble. Put a 0 right here. Negative 2. 2 times the log of x plus 5. Subtract the 5 and divide by negative 2. So the log of x equals 5 halves. 10 to the 5 halves equals x. X equals what? That should have, what you punched in should have been right.
That's correct, but it just doesn't make sense.
It doesn't make sense. See if it matches on the table. Somebody still have it on the table?
Yes.
Which one are we doing?
40?
Well, yes, but are we doing
What?
g of x or f?
G of x.
For 316?
No, well, yeah. Yeah.
Got you set up.
Excuse me.
316.
No, it's a really
I don't,
tiny
put that
number.
away.
Yeah.
It's not 0, but it's really tiny.
0.63.
Well, okay, so it's really, really tiny. That could just be like a logic error in the calculator.
No, it's because it's 316 point something. That's where the 0 is.
Oh, yeah. You're right. Yeah, so that's correct. That's all accurate. So it crosses the x-axis at 316.
Right, 'cause
Ish.
it's flipped. Because of the negative, it's flipped. So for it to go all the way down.
Oh, yeah.
That's why. I was looking at the parent function. It's like, how the heck did that work?
Yeah, because it doesn't get there until way over there.
Okay. Now
Yes.
multiplication
Yes.
sometimes.
And then we'd graph the things, plug in dots. We might want 1 or 2 more dots, who knows, and then you do it and you graph it. Great, easy money. All right, any other questions before we play with a few more of the evaluate
We
ones?
should do 32. Yes.
Okay,
22.
32.
32.
All right.
Wait, never mind.
Okay, are you sure?
Yeah, I'm fine.
Okay. All right, any other questions before we have some fun?
Let's have some fun.
All right, let's do all of 1 through 23 odds. We'll do them together and separate. We'll do them. Y'all go ahead and I'll give y'all a head start. And then I'll start doing things, and then we'll compare notes.
Come on, stupid.
Don't rush, it's not a race. This isn't Algebra 1. Hello? No calculator allowed except on, let's see, let's find out which ones. 9, 11, 17, and 21.
9, 11, 17, 21.
Other than that, no calculator allowed. Probably. That was pretty yummy. Eggs, I love good egg salad. It's delicious. I'd get tired of it, but. Are you having too much fun? Look, it's a targeting stick. All you need is a clicker. All you need is, it's a targeting stick. All you need is a clicker. And the parrot goes, and then you click it and give it a treat.
Is it okay if I check my answer on my calculator?
No.
No?
You can check it off the whiteboard.
This is good for me, anyways.
What are the ones we're allowed to do a calculator right now?
9, 11, 17, and 21.
Can we use it on 3?
No.
Oh, I don't even need it. Just kidding.
That exists, right?
There's no rhyme or reason, and there's no explanation to why they would want you to do this, but they have it. They put their answers to 4 significant figures on the odds, and then on the evens they do it 3 sig figs. So I don't know. No, there's not. Like, if you want the answer to be matched perfectly on number 9, 4 sig figs is what they used. But which in this context would mean that they rounded to the thousandths place. You should, real quick before you move on, punch 19 in your calculator and see what happens.
Oh, art.
Ooh. Because think about it, right? They go like that. They're never going to get over there.
How are y'all
Yeah.
already on 9?
Because I was doing some of these while y'all were doing like 40. So I didn't have covered 40.
Boom, boom, ba-dum, doo, doo. So how was it, Nathan?
I wrote a 2 instead of a 3 on Kramer's roll.
Which ruined everything.
Wait,
It was
which-
also on
are we supposed to go through 23?
Yeah,
terminal X, so I didn't see it until.
till later. Nice. Well, at least it's easy to catch when you do Kramer's rule. If you're doing elimination, it'd be like, okay, I give up. I'm done. Clearly, I did something wrong, but I'm not going to go figure it out. With Kramer's rule, it's like, okay, I know where I made a mistake. Let's go find it.
Yeah, right. I pressed the wrong thing.
I think I got everything right.
Nice. just that whole column.
What in the world?
Oh, that's funny.
What?
This problem,
Which one?
number 7.
Yeah, number 7's, I don't like it.
Is that cubed? Is it cubed? No, it's to the 4th, right? I think it's to the 4th. Does that match the key? It totally does. That's kind of a funny problem. Magic.
Oh, I did it a different way.
I know you did. Yeah, and you doing it the longer way will get the same answer, but
Bruh.
I like the longer way.
yeah.
Why am I so dumb? It was so easy.
Yeah, but do you understand why it was so easy?
Yes, it is.
Yeah. Because you could have done it just like we did that other one. Yeah, absolutely.
And I was an actual.
Yep, me too. I was about to do it that way. I was like, wait a minute. Wait a minute, we could do that.
What were you about to do?
I was about to do
9
like
to the 1/2.
9 to the 1/2 equals 9
The 1/2
squared.
dx
Yeah,
equals
yeah,
9
exactly.
squared.
And then
And you eliminate
all the things and
the
yeah,
9, so then you have
yeah,
2,
like we
1/2 x
like we did number 22. Nine is 1.623. 11 is 3.722. 17 is 2.803.
Wait, what?
17 is
You
2.803.
started saying numbers and I lost like all of them.
Okay. 9 is 1.623. 11 is 3.722. 17 is 2.803. And 21 is 2.079. These, by the way, these problems like these are the types of problems, we've seen these before, but I don't know that we've seen them in pre-cal, where like if you did number 3 on a test, if I gave you number 3 on a test and you just wrote -2 and circled it, I would count it wrong. I need to see that you know how to get there. I don't care if you can push buttons on your calculator. I mean, I do care about that actually, because that's a skill we're actually working on, but I want to know that you can figure out how to get there.
Negative coming from them.
Because of the fraction, right?
Oh,
So
yeah.
6 squared is 36, and then since it's in the denominator, it's -2. Log of e to the 4th is 12.
How do you do 9?
Punch it in the calculator. 9, 11, and 17 and 21, you can just shove in the calculator. There are, like pre-calculators, just in case you care, which you probably don't, but I'm gonna yammer away anyway. There are ways to simplify those radicals. Actually, we're gonna remind you of some of those methods and whatever. And then you would go back and look at the table of what is the log of 3, and it would tell you point whatever, and then you would get the answer. But we are going to do problems like that. Everybody's favorite. I think that's in the next lesson, actually. Is that in the next lesson? Let me see. I assume we're doing that in pre-cal. That's what I feel like is going to happen. Let's find out. Evaluate. Yep, we are going to do it. Although, intriguingly, it doesn't give it to you in the homework. Does it give it to you back in the notes, what log of 2 is, log of 3 is? It doesn't, so how are you supposed to do that? Oh, no, just kidding. LOL, JK. No, just kidding. It's different, yeah. That's the difference between this and the algebra 2 problems. Is we leave it exact and uglified. In algebra 2, we get a stupid looking decimal without a calculator. Yes. So yes, in the next lesson, you are going to remember how to do those things.
do number 12 in your head?
Number 12. You had number 13?
Kind of. So, what would we do with this 4?
Move it over to the left.
Yeah, so over here, so then it'll be 4 times 3. And the natural log of E is what?
Oh.
Is 1, so,
So then 3 times 4 times 4
yeah.
is 12.
Okay.
Yeah, so kinda. Yep. $36. The 6th, no, something root of 6. 5th root of 6. Wow.
And you can turn 5th root of 6 into.
I don't like that.
Yes, you can. What?
Into something.
Yes. 6 to the something
It's like 6 to the 5th?
to the 1/5.
The 1/5? Oh, yes.
The
to
1/5.
Yeah.
Yes.
What's 1/5 divided by 2?
2/5.
What?
2/5.
Oh, no.
No. 1/10. Because it's 1/5 divided by 2, which would be 1/5 times 1/2.
Oh.
Right?
Oh, we can put it into exponential. I don't have. I need to get exponential form from those.
Can we use a calculator on 19 or is that not allowed?
19 you don't need a calculator for. You can't take the log of a negative because it doesn't exist over there.
So.
Number 23 is a dumb problem. Oops.
Oh, and those will put together. Ah.
Okay.
I don't know how to do that.
Oh, look at me go.
Nice.